Hello everybody, welcome back to our channel in this LeetCode series. Today we are going to solve LeetCode problem number 7, which is reverse integer. At first glance, this looks like as an easy math problem, but there once interview trap that caused many candidates to fail, which is integer overflow. Let's understand the problem and then intuition first, then code it with together. So we are given an 32-bit integer, which is x, and return x with its digit reversed. If reversing x causes the value to go outside the signed 32-bit integer range, this given, and then return 0. Uh, Assume this the environment does not allow you to store 64-bit integer, signed or unsigned. So our task is to reverse its digit. For example, here is 1 to 3 becomes 3 to 1. And in minus 1 to 3 becomes minus 3 to 1. And 1 to 0 becomes 2 1. Because leading 0 disappears. But here is the important condition. If the reversed number goes outside the signed 32-bit integer range, we must return 0. So how do we reverse a number without converting it into a string? Let's take example. Uh, let's see here as example 1 to 3. So let's take 1 to 3. First, we extract the last digit by modulo by 10. So here you can see that uh, I have modulo 1 to 3 modulus 10. So after this we will get 3 as a remainder, and again we will remove this, then we have left 12, and again if we will repeat this process, then we will get, you can see given we have taken the number as 1 to 3, but after modulus and repeating this process again and again, you can see what we will get, 3 to 1 as final result. So this is how we can reverse this integer. So, and after this, how we will reverse? We will use a formula which is we will store reverse is equal to reverse into 10 plus digit. We will do this formula. We will see on code. So now we are going to code. Let's together code. Now first we will create a variable to store our reverse number. So we will create a variable and initialize with it 0. Uh, Now we will process every digit until the number becomes 0. So we will write a while x is not equal to 0. Then extract the last digit. Now we will extract the last digit. So digit is equal to x modulus 10. Now comes the most important part, overflow checking. Uh, Before multiplying reverse by 10, we must make sure it still fits inside the 32-bit integer. If it does not, we immediately return the 0, as you can see here is given. So now we will write the condition if reverse greater than int max divided upon 10 or reverse equal to int max divided upon 10 and digit greater than 7 because for 32-bit maximum number is I think 2.1 billion. So we are checking that contains 7 digits, so we are checking for 7 digits. And if this, we will return 0. And another condition for negative number, uh, if reverse greater than int min divided by 10 or mm, reverse equal to int min divided by 10 and digit less than minus 8. Uh, in this case, we will return 0. Now our overflow condition has checked. Uh, Now if the value is safe, append the digit and reverse this. So now we will write reverse is equal to reverse into 10 plus digit. Finally, remove the process digit, process digit, and like we will remove the process digit by is equal to 10. Now, finally, we will repeat until all digits are processed. We will remove the process digit, and finally, we will return the reverse number. Return reverse. Uh, so let's check for test case. So the entire solution is based on just three steps. So here I have put, yeah, this is at the place of dollar, we must and operator. Hmm. Let's check again. Hmm. What problem has caused? Oh my God, a spelling. I have mistake in writing the spelling of digit. This is very disgusting, man. Sometimes we got error. So yes, our test case is passed. So the entire solution is based on just three steps. Extract the last digit using modulus and with 10 and removing it using divided by 10. Append it using the formula reverse is equal to reverse into 10 plus this. The only tricky part in this question is checking for overflow using this condition. These two conditions we have checked, one for positive overflow and next for negative overflow. The solution eh, run in big O of log n time because we process one digit at a time and it uses big O of one extra space. Uh, if this explanation, so I am going to submit this question. So yes, our answer has submitted successfully. So if this explanation helped you to understand the logic instead of just memorizing the code, subscribe for more LeetCode problems solutions in C++ with better understanding trick and for further interview questions where we will focus on intuition first and code second. See you in next one. Thank you.